Hi guys, this is going to be your chapter review. You're assigned the even ones, so I'm going to do the odd ones with you. We're going to have a quick review on graphing, okay? First, you have to be able to put words into some kind of inequality um, sentence, right? So a number W is greater than -3. So if we had -3 on a number line, it can't be equal to -3, but it would be anything greater than that. So if you're greater than, it's moving to the right. So any of these values would be greater than -3. If you were to plug it in, you could go -1 is greater than -3. So our inequality would be x is greater than -3. Next, they give us the inequality and we have to solve it and then figure out whether 7 is a solution. So we have 5 plus j is greater than 8. First, we're going to add or subtract whatever is on the same side as our variable. So instead of adding, we're going to subtract 5 from that side, and whatever you do to one side, you have to do to the other in order to keep it balanced. This cancels out, and we have j is greater than 8 minus 5 is 3. So on a number line here at 3, it can't be equal to 3, so we're going to have an open circle. Any number larger or greater than 3 is a solution. So 4, 5, 6, or 7. So 7 is a solution. And on the drop-down menu, we would say is. Now we're going to graph this inequality on a number line. Q is greater than -1.3. So we're going to put an open circle at -1.3. If it's greater than, it's moving to the right, okay? So 0 is greater than -1.3, and we would plug that in there and say, yep, that's true. Now, an inequality that represents this situation. You're at an amusement park and you are going to ride the bumper cars. Now, you have to be at least 42 inches tall to ride the bumper cars, which means if you are 43 inches, you are A-OK. So here's our little guy. He is 41 inches. He can't ride it. If he was 43 inches, he can write it, right? So our inequality would look like here at 42. If you're 42 inches, you can write it as well. So we're going to have a closed circle. Any number greater than that, you can ride. If you're 43 or 44, you are a happy camper. You get to ride the bumper cars. So we're going to add or subtract whatever is on the same side as our variable. So instead of subtracting 4, the opposite would be adding 4. Whatever you do to one side, you must do to the other to make it balanced. So t is less than or equal to -14 plus 4. On our number line, we'd be moving to the right from -14. So our answer would be -10. So if we were to graph this on a number line, we'd have a closed circle at -10, and we would be moving, to any number less than -10. So it would be moving to the right. So -9 is greater than. That would not be a solution to this inequality. Only numbers that are less than would be solutions. So here, we are not adding or subtracting anything on the same side as the variable, but down here, we have something times the variable. So we're going to again think about the opposite operation. The opposite of multiplication is division. So we're going to divide both sides by 6. 6 divided by 6 is just 1. So we have just q is less than -18 minus, or divided by 6. So it's still going to be negative because we still have just one negative. 18 divided by 6 is 3. So q is less than -3. So here at -3, what kind of circle do we have? If you said open circle, you're right. Less than. So would it be -4 or would it be -2? I always think about negatives like I owe somebody money. Would you rather owe somebody $3 or $4? Oop, yep, that's more negative. So it would be less than -3. Another thing you can remember is that it's going to move to the left if it's less than. Okay, this one is a little tricky. We have 4/3 times s. So I'm going to put it in parentheses to just remember we're multiplying these together, right? Now we want to do the opposite. So we would want to divide by 4/3, right? Well, you remember with fractions, in order to get that to equal 1, we would have to multiply by the reciprocal. So we're going to multiply by a -3/4. And that cancels out, and that cancels out. And here on this side, we are left with just s. But whatever we do to one side, we must do to the other. So we're going to multiply by -3/4 over here. We can turn this whole number into a fraction by just giving it a denominator of 1. So here we are going to multiply -3/4 times -4. Now, when you're multiplying fractions, you remember if you see something with a common factor on the top and the bottom, you can divide the top and the bottom by that same number. So here we're going to divide by 4 on the top, divide by 4 on the bottom. Then when we multiply straight across, we have -3 times -1, which would just be 3. The negative times a negative cancels out the negative, and it's positive. 1 times 1 is just 1. So hey, we have 3 is greater than s. So on a number line, we would have an open circle at 3, and we would say, this is backwards. This is different than how we're used to seeing it. If you want to rewrite it, you can rewrite it with your variable first, but you have to know that the same side of your inequality symbol that was pointing at the variable still has to point at that variable, okay? So we'd say s is less than 3, okay? And your line would go this way. So 2 or 1 would be a solution. Now, we're always going to double check, so we would rewrite this and say, is 3 greater than 2? Yes, it is. Here we're getting to a little bit more complicated inequality, so I want to talk you through the steps. The first step is to add or subtract the constant on the same side as your variable. So here we're subtracting 6, we're going to add 6 to both sides. So then we're just left with x over -2 is less than or equal to -2 plus 6 is 4. Okay? Our next step is going to be to multiply or divide to get rid of the coefficient on the same side as your variable. But whatever you do to one side, you must do, whatever you do, do it to both sides. That is the only way it's going to be balanced. So instead of dividing by -2, we're going to multiply by a -2. Multiply by a -2. This cancels out. We are just left with x. Oops, but we just multiplied or divided by a negative number. So we must flip our inequality symbol. 4 times -2 is -8. That's the only time we're going to flip our inequality symbol is if we multiply or divide by a negative number. So on a number line, we would have a closed circle because it can be equal to -8. And we're looking for numbers that are greater than -8. So it would be a line pointing to the right. So now we have parentheses. So our first step is going to be the distributive property. 7 times q is 7q. 7 times 2 is 14. It's less than -77. So we're going to add or subtract whatever is on the same side as our variable. So we're going to subtract 14. Whatever you do to one side, you have to do to the other. This cancels out. These are both negative, so we can add them together knowing that their sign will be negative. So we carry the 1, 8, and we have 91. So we have 7q is less than 91. We're going to divide both sides by 7 and find that q is less than 13. Now we did not have to flip the direction of the inequality symbol because we were just dividing by a positive number. We only flip it if we're dividing by a negative number. So we're going to have what kind of circle here at 13? Open circle. You're right. Q is less than, so we're moving over here. So 12, 11, all of those would be possible solutions. Okay, this is our last one. We have parentheses, distributive property, 1.2j, and then 1 plus 1.2 times 3.5. I can't do that in my head, so we're going to have to do that later. It's greater than or equal to 4.8. So let's do this. We're multiplying decimals. We have to remember that our answer is going to have the same number of decimal places as the two things we're adding together. So this has 1, this has 1 decimal place, and we find that by putting our finger on the decimal point and counting how many numbers to the right. Then our answer has to have the sum of the decimal places of your products. Okay, so that means our answer has to have 2 decimal places. So I'm going to box this off. We're just keeping track of decimal places. 5 times 2 is 10, carry the 1. 5 times 1 is 1 plus 5 is 6. 3 times 2 is 6, 3 times 1 is 3, add it all up, and we have 0, 2, 420, but we know 1 times 3 would not be 420, so we have to put our decimal point in there. So we have 1.2j plus 4.2 is greater than or equal to 4.8. This looks like we're used to seeing. So now we're going to add or subtract whatever's on the same side as our variables. We're going to subtract 4.2 from both sides. 1.2j is greater than or equal to, this would be 0.6. Now we're going to divide both sides by 1.2. Divide by 1.2. J is greater than or equal to, oh dear, I can't do that in my head right now. So we're going to go 0.6 divided by 1.2. And this is a good chance to remember how we divide decimals. If the number outside of your little house, like I call it, has a decimal place, you need to move the decimal place over until there are no more decimal places here. Put it there. And however many places you moved on the outside, you have to move on the inside. So now we have 12. How many times does 12 go into 6? Well, it doesn't. So let's add another digit, another 0 there. Move our decimal point straight up. 12 goes into 60 5 times. And that works out. So that's 0. So here we have j is greater than or equal to 0.5. So we're going to have a 0.5. Here we would have 1, and here we would have 0, right? We would have a closed circle, and we would say j is greater than, so it would be moving here. So we would say 1 is greater than or equal to 0.5. That's our quick check. It checks out, and we are done. Congratulations, you guys made it through the review. I hope you guys understand this and hopefully watched along and were able to do your work as you watch this. Bye, you guys.